Hey guys, so today I'm going to give you some notes over matter. Last week we mostly focused on mixtures, so I'm just going to review some of those terms with you. So last week when we talked about mixtures, we know that mixtures are physically combined, which means they can also be physically separated. And you guys did excellent on your separation quiz. Um, and so we just want to make sure that we all understand that mixtures are something that's physically combined or physically separated, and that they can be in any ratio. There's not a set ratio of when you're making trail mix, right? My daughter would have 90% of it be M&Ms, right? Maybe a few cashews thrown in there, and that's all she needs. Um, and so mixtures can have any set ratio when it comes to how they're made. This is not focusing, so we're going to see. Something got bumped. There we go. That looks better. Okay. So when we talked about mixtures, we talked about two types of mixtures, right? We talked about how there were heterogeneous mixtures. Those were the kind of mixtures that looked different throughout. And that was because they had a large length scale. So heterogeneous mixtures were the ones that could be filtered, or they could use decanting. We could use simpler physical techniques to separate out those mixtures. Then our other type of mixture that we talked about was homogeneous, or homogeneous if you want to pretend like you're sounding extra fancy, right? And so homogeneous meant that it was the same throughout, so that it had a small length scale. And we called homogeneous mixtures or homogeneous mixtures solutions, right? That's a good word. Remember that homogeneous and solutions go together. And that solutions were made of solutes that dissolve into solvents. And that was a lot of vocab that we covered last week, right? So this week, we're going to be focusing on the other side of matter, right? We're going to be talking about pure substances. And in talking about pure substances, just like there was two types of mixtures, there are two types of pure substances. Our first type, it might be easier if I just make a small arrow down, and then we'll make a bigger arrow and use more of the paper, are called elements, okay? So elements are our first type of pure substance. Elements is made of only one type of atom, okay? And when we see the word atom, that's another definition that we got from our card sort, that an atom is the simplest form of an element that maintains its physical and chemical properties. Okay? And so after we did this one type of atom, that's what we're going to call an element. However, in this category of elements, we actually have two different types of elements, okay? So we're going to talk about monoatomic elements versus diatomic elements, okay? So mono has the prefix, and that means one, right? That's only one atom. So think about things like copper or aluminum, right? It's just one type of atom. So you might show one, and and the other one you might like color in, right? But you could show them as just single atoms. That could also be an element, right? For diatomic elements, di means two, right? These are two atoms of the same type, and there are 7 of these that you must memorize. Okay? So we're going to list our 7 diatomic elements. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, because we pronounce that one differently just for fun, right? And so one way to remember your 7 diatomic elements is that they all end in "-gen" or they end in "-ine", and so I call them genuine. Other ways you can remember your diatomic elements is that when you look at them on the periodic table, they form a 7, except for hydrogen is in the far corner, being the first element on the periodic table. And there, Miss Smalling prefers Brother Honcliffe as a way to also remember her 7 diatomic elements. But these are elements, it's only one type of atom, right? They're on the periodic table, and so you might show them bonded together or, right, like something like that, right? So that would be a diatomic element. Okay. The other thing about elements is that they're always going to be found on the periodic table. It's called the periodic table of elements because it's a list of all the elements known that we have to date that we've come up with. Either we found them or made them man-made. Because I'm running out of space, I'm just going to move this over. There we go. Okay. So in our continuing our discussion into pure substances, another pure substance that isn't elements are called compounds. Compounds is more than 2 elements that are chemically combined, which means they can be chemically separated. And the thing about compounds, different than a mixture, is that compounds have to have a set ratio. Think about like H2O versus H2O2, right? This is water. It's very refreshing, right? Makes up most of the earth and you. This is hydrogen peroxide. Not quite the same, right? You would not drink H2O2 in that ratio as you would H2O. This would make you vomit right back up, right? You. And so that set ratio means that compounds always have a formula. Okay? So H2O might look like that, and H2O2 would look differently, right? But they would be bonded together chemically combined, right? And we're going to have more than 2 elements, more than 2, right? There'll be different elements bonded together chemically in a set ratio. That makes a compound. But then we get into an odd terminology here in the middle, and that's the word molecule, right? So a molecule refers to anything that has been covalently bonded. We'll talk more on Friday about the difference between covalent and ionic bonds, but for right now, if you just want to remember from 8th grade that just means to share electrons, you can. And the word molecule mostly is going to refer to compounds, right? like water or hydrogen peroxide. But a molecule can also refer to a diatomic element. They are covalently bonded, right? That is an H. Hydrogen would be an H bonded to another H. Water is an O, an oxygen bonded to two other H's. So though they're both molecules, this one is the same element, right? So this is an element and a molecule, whereas water would be a compound and a molecule. And so be careful with this word molecule because it can mean anything that is covalently bonded. If there are two or more elements that are chemically bonded, then we call that a compound. And if it's the element bonded to itself, then if it's one of these 7 diatomic elements, that can also be called a diatomic molecule. Okay. There's a lot of vocab on this page to think about, right? So you need to know the word element, you need the word atom, right? You need to know the word molecule, the word compounds, and how to classify the matter as we go. And so you can have a mixture of compounds, you can have a mixture of elements in compounds, or you can have a mixture of elements. So now what I would like you to do is to practice putting these terms into a picture form by completing the classification PL.